Hello, 6th graders. Congratulations, it's Friday. I'm sorry I'm not in class today, but my tennis team is actually playing in the first round of conference. We're playing Loris today, and if we win, we continue to go and play tomorrow, so I'll be supporting the Dutch. Even though I'm not there, Miss Temple should be there to answer any questions that you have. Throughout the week, we've been working with the ideas of potential and kinetic energy, and we've been demonstrating that now through the building of our balloon-powered cars. So you're pretty much going to have the whole class period today to work on your cars. Yesterday you should have started your build, and today we will be fine-tuning that build. So here are a couple things to keep in mind. Number 1, your car must travel at least 3 meters. Number 2, your car must weigh less than 20 grams. Number 3, the challenge is to make the least expensive car possible. When you think you've built your car to a point that you're ready to test it, I have a few guidelines I want you to follow. This is the sheet we're going to use to track any changes we make and make sure that we're running fair trials. We're going to make sure that we're running fair trials, meaning that we're only changing one variable at a time. We're going to change one variable because if we change more than one at a time, there's no way to tell exactly which variable made the difference. And when you make a change, you're going to write down the change right in this column here, and you're going to make a prediction. And then over here, you're going to write down how I actually did. It would probably be a good idea to write down the distance that your car actually travels. So after you test your car one time, you can go back and you can make another change. By the end of today's class, you want to make sure you have your car ready to go for Monday. Here are a couple tips on how we're going to measure that. Now we're going to put down a line. You will put the front of your car on that line, and you will blow up your balloon and it will go. We're going to use a string to measure it, so we're actually measuring the distance it takes even if it curves. So how we're going to do that, we're going to take a string and we're going to trace that line behind your car as it's driving, and then you'll take that string and you'll go ahead and measure the length of that string, and that will be the distance that your car travels. So here we go. I'll go ahead and demonstrate one example for you, and then you guys will have the rest of the class period to work. Alright, so here's how we're going to test our car. We're going to have a line taped on the ground, and then we're going to have some string, and you're going to place the back side of your car on the line, and then once you release your balloon, you'll take the string and you'll trace the path, and that way if it curves, we can go ahead and measure the total distance that it's traveled. So I'm going to go ahead and demonstrate mine for you. Alright, so once I release it, I'm going to go ahead and trace the path with the string. Right into a cabinet there. But this allows us to measure from where the car started, and then we're still measuring the back side here at the end. So you'll go ahead and take that spot and the beginning spot, and then you'll measure the distance in between those, and that'll be how far your car traveled. On Monday, we will be doing our final tests. Using the same measuring strategies. You will get 3 trials, and then you will average them. You will also have to have your car weighed and your price, and we'll put it all into a big collection sheet for data, and then we'll go ahead and analyze that as a class to find out which variable has made the biggest difference in our car. Alright, so that's all I've got for you guys. So you guys are going to have the rest of the day to build. Miss Temple should be roaming the classroom. If you have any questions, feel free to ask her. Good luck!